dirt. Around 5 million tons of it flows down this stretch of the Missouri River every year until it reaches the lake where it falls out of suspension. Since the 1950s, when the dam was built, the sand and silt have built up a massive delta where the river comes in. The reservoir has already lost about 30% of its storage capacity, and one study estimated that by 2045, it will be half full of sediment. Downstream, the impacts are mostly environmental. We think of rivers as carriers of water, it's right there in the definition. But if you've ever seen a river that looks like chocolate milk after a storm, you already know that they are also major movers of sediment. And the natural flow of sediment has important functions in a river system. It transports nutrients throughout the watershed. It creates habitat in riverbeds for fish, amphibians, mammals, reptiles, birds, and a whole host of invertebrates. It fertilizes floodplains, stabilizes riverbanks, and creates deltas and beaches on the coastline that buffer against waves and storms. Robbing the supply of sediment from a river can completely alter the ecosystem downstream from a dam. But if a river is more than just a water carrier, a reservoir is more than just a water collector, and of course I built a model to show how this works. For most reservoirs, the whole point is to store water for controlling floods, generating electricity, drinking, irrigation, cooling power plants, etc. So as sediment displaces more and more of the reservoir volume, the value that reservoir provides goes down. And that's not the only problem it causes. Making reservoirs shallower limits their use for recreation by reducing the navigable areas and fostering more unwanted algal blooms. Silt and sand can clog up gates and outlets to the structure and damage equipment like turbines. At that point, it's just hard for the benefits to outweigh the costs. There's a reason we don't usually dig enormous holes to store large volumes of water. I mean, there are a lot of reasons, but the biggest one is just cost. Those 5 million tons of sediment that flow into Lewis and Clark Reservoir would fill around 200,000 in-dump semi-trailers. That's every year, and it's assuming you dry it out first, which, by the way, is another challenge of dredging. The spoils aren't like regular soil. For one, they're wet. That water adds volume to the spoils, meaning you have more material to haul away or dispose of. It also makes the spoils difficult to handle and move around. There are a lot of ways to dry them out or de-water them, as the pros say. One of the most common is to pump spoils into geotubes, large fabric bags that hold the soil inside while letting the water slowly flow out. But it's still extra work. And for two, sometimes sediments can be contaminated with materials that have washed off the land upstream. In that case, they require special handling and disposal. Many countries have pretty strict environmental rules about dredging and disposal of spoils, so you can see how it really isn't a simple solution to sedimentation, and for most cases, it often just isn't worth the cost. Another option for getting rid of sediment is just letting it flow through the dam. This is ideal because, as I mentioned before, sediment serves a lot of important functions in a river system. If you can let it continue on its journey downstream, in many ways you've solved two problems in one.